This video we're going to talk about factoring trinomials when our a term is equal to 1. Now, what I mean by this is the a term, my a value, is the coefficient of my squared term. So in this case, both examples here, there is no coefficient, which means that it's default 1. So this type of factoring, I would have already looked for a GCF. Okay, so there is no GCF here. I would have also gone through and checked to see if I could factor using difference of perfect squares, but these are not binomials, they're trinomials. So what I need to do is factor this trinomial here. Some teachers call it the AM method because I'm looking to see what adds to the middle term and what multiplies to the third term. I've heard people call it unfoiling, the list goes on here. I just call it factoring trinomials when a is equal to 1. And what I'm going to do is I'm going to make a chart here. So I want this to multiply to 18, and this is positive 18, just taking the constant here, and I want it to add to 11. Again, it has to add to my middle term, but multiply to my third term. Now there are infinitely many numbers or pairs that add to 11, so I actually want to look at what multiplies to 18 first. And I can just rattle off some numbers here. So 3 times 6 gives me 18. But if I did 3 plus 6, that only equals 9, so that's not what I'm looking for. If I had 1 times 18, well, that equals 18, but 1 plus 18, that equals 19. That's not what I'm looking for. And finally, 2 times 9 equals 18, and 2 plus 9 equals 11. Hey, ding ding, that's what I'm looking for, which means my two factors are positive 2 and positive 9. I set up two sets of parentheses the same way I would when I'm factoring with difference of perfect squares. And what am I going to multiply together to get a squared? Well, in this case, a times a. And the factors that I found here that multiply to 18 and add to 11, I'm going to put positive 2 or plus 2 and plus 9 there. Okay, and you think you still have more to do, but you're actually done right there. I could check my answer by using the box method, but I'm not going to do that here. It should give me my original answer up top. And my next example here, n squared plus 4n minus 12. Again, I'm going to set up my chart here. I'm looking what adds to positive 4, but what multiplies to negative 12. Negative 12 adds to positive 4. And if you start rattling off some numbers, however, when you multiply to be a negative, you know one has to be positive, one is to be negative. So think of 3 times negative 4. That certainly gives us negative 12, but if I add it together, I get negative 1. That's not it. 12 times negative 1. Now, I'm just doing this to show you guys some different scenarios here. However, if you did find it on the first try, you're done there. 6 times negative 2. 6 plus negative 2 is equal to 4. Ding, ding, there's my choice. So those are my two factors. If you notice, one's positive, one negative. So I need to set up my parentheses here. N plus 6, n minus 2 is my final answer. Again, I would double check my work by distributing or using the box method to make sure I had my original answer. So again, just two examples here for using factoring trinomials when a is equal to 1, and I hope this helped, guys. Thanks a lot.